Welcome back to Maths with Mrs. J. I feel like doing a few challenges today. I've already done one. I want to do this fun limit as another example. This limit is really cool for a number of reasons. It brings in a number of different areas of senior high school maths, and it has a really nice simple answer, so it's really cool. We know that if we have a limit like this, where we're taking the limit as x tends towards 1 of something where if you were to sub in, you'd get 0 on 0. We can't obviously sub in. So we need to think of alternatives. Ideally, we'd like to be able to divide this through by our x minus 1. Now let's just imagine for a minute that we had a polynomial, p of x, and it's x to the 1000 minus 1. Well, p of 1, we've already worked out as 0, because if you sub in x as 1, is 0. So yes, x minus 1 is a factor. Now, obviously, it's going to be a complicated expression you get, but let's just sort of have a bit of a look at it and we'll be able to get started on it and see what the pattern is. So if we're doing x to the 1000 minus 1 divided by x minus 1, leading term divided by leading term, we get x to the 999, multiply through minus x to the 999. When you do your subtraction, you get that. Then, of course, divide through again and you get x to the 998. Again, multiply through. And we get this. Now, you might see a pattern starting to develop. Eventually, we get down to x squared minus 1. So plus x squared divided by x is x. Then we get x squared minus x, do our subtraction x minus 1, and finally we get one lot of x minus 1, and of course we get 0 remainder. Sorry, I don't know why I always seem to write uphill, but anyway. So what we actually found was that x to the 1000 minus 1 on x minus 1 is really this expression here, x to the 999 plus x to the 998 plus all the way down to 1. I'm going to actually write it in the other order. So we're going up in increasing powers of x all the way up to x to the 999. What does this make you think of? Well, hopefully it does ring a few bells. This is a geometric series. You're multiplying by x to get each next term. We've got our first term is 1. Our r, what you're multiplying by each time, is x. Our n is 1000 because you've got 1000 terms. Sum to n terms of a geometric series is a times r to the n minus 1 on r minus 1, which of course is 1 times x to the 1000 minus 1 over x minus 1, which is what we started with there. Kind of cool. All right, so what we can now do is we can say, well, this is the limit as x tends towards 1 of just this expression here. So 1 plus x squared plus x to the 998 plus x to the 999. Well, you've got 1000 terms there, and each of those 1000 terms is going to equal 1 when you substitute in x equals 1. So we're going to get 1000 times 1, which is just 1000, which I think is pretty cool.